So this is day 21 and I am Alok Srivastava. So the objectives of the day are we will be learning what ISCSI is, understanding ISCSI. We will be learning the different types of storage types like DAS, NAS and SAN, though it is not in the your course content, but I intend that you should be knowing the basic differences. And then finally we will be learning how to configure a ISCSI target and a ISCSI initiator, and it is an exam objective also. So very important topic. Let's start with the basic things that what exactly the iSCSI and different types of storages are. We will do that. Now, the business these days, the business information and the data repositories are very important to the success of any business. And the storage sits in the center of any information access system. And nowadays, the storage is getting faster, smaller, and on gigabyte basis much more cheaper, and the technology has evolved from DAS, then NAS and SAN, and now we have iSCSIs with us. So the storage is very important for us. How we are going to access the storage? So iSCSI offers an additional storage option on the promise of simplified management and the reduced cost. But before I jump onto that, I would like to have a small talk about the DAS, SAN and NAS. So what exactly these storages are? So DAS, as you can see it on the screen, I've got a picture here, direct attached storage. It is like the one hard disk in your laptop or your server. So in this case, the hard disk is directly attached to the motherboard or the main board. Very simple stuff, like you have got a hard disk attached in your laptop, like a USB storage device or a pen drive which you connect to your laptop is a direct attached storage. In SAN, or the storage area network, is connected to the host or the servers, but it is connected via some backplane using some expensive adapters, cables, and the connections may vary from fiber channel to iSCSI or serial attached SCSI, or we call it SAS. So SAN is comparatively much more expensive than your DAS. And then the other type of storage we have is the NAS storage. What is NAS? How it is different from DAS and SAN? So NAS is your network attached storage, and like suppose it's something like I share my file on the FTP or Samba or Apache. So when I'm sharing the files over or accessing the file server remotely using the TCP IP, we call it a NAS. So it's normally known as the file servers. The servers is obviously the server will have its own attached DAS or SAN, and the sharing is being done using the network file system like Samba, FTPs, and Apache using the TCP IP obviously. And we are going to see how it works when we will be configuring the Samba and Apache and FTP later in the classes, but not right now. So as if you can see in the screen, here is a small comparison between a NAS and a SAN and a DAS. So let's see what are the major benefits of using the DAS, what are the plus points, and what are the negatives or the features of these different types of storages. So as far as the DAS is concerned, the DAS, the plus points are it's very simple to set up, simple to configure. I don't need a network, because if you attach a hard disk on your laptop or a pen drive on your laptop, you don't need IP address. It's cheaper, it is much faster than SAN and NAS, and it is easier to deal with. The negatives or the minus are, okay, it's we need to have it is dedicated to a machine. I cannot share it. It cannot be managed over the network, and it requires special hardware connection like your SCSI drivers or SCSI adapters are required. So these are the negatives. So if I have got a file in my hard disk, I cannot share it to you. So that means it is dedicated to a single computer, which is obviously a negative side. Then we have got NAS. So the plus points are, okay, it is very economical to provide a large storage. It is easier to set up than SAN, And the best part is that it allows me a user level permission access, as you can see on the picture. Like I can control that which file or folder will be accessed by which user. So I can have a file level access or a folder level permission. User permissions can be defined. So I can control all these things, and it gives me a high utilization of my resources. I'll be able to use my hard disk among hundreds of machines, which is great. The negatives or the minus is that it requires an IP address and a network space, and it can be slower depending upon which file system you are using on your FTP or Samba or Apache, and it consumes your network bandwidth. So you have to take care of that which file system actually you are using to have your file sharing available via Samba or FTP or Apache. So that need to be considered. Then the next we have got the DAS. So SAN. So before we come on to the SAN, we know that DAS was very good at speed, and more speed, like something like Fast and Furious. And the NAS was good at sharing, flexibility, resource utilization. So SAN combines the best of both the NAS and the DAS. It combines both the things. So the plus points of the SAN is it gives me the economies of NAS, the speed of DAS, and the best part is that it is compatible with the virtual like environment and the cloud computing stuff. You know, the cloud computing, every major companies are going onto the cloud. So here is a joke for the cloud. According to this, the planet Earth was populated by humans till 2012. Then they have moved to the cloud. So that's good. Enjoy the laugh. Now come back. Minus are you need multiple IPs, complex network planning, it's very expensive, and the physical cabling need to be planned very carefully. That is one of the major issues. So now what does iSCSI offers? So as I have told you earlier that iSCSI gives me an additional storage option on the promise of simplified management and reduced costs. As you know that IP is the most widely used standard anywhere, and IP is easy to implement and it's very affordable, and the most corporate data traffic uses a common IP address. So that means if I am a company, so all the machines in my network will have the same IP address except the storage data. As you can see it on the picture, the communication will be done on the IP, and then the iSCSI will automatically convert the commands to the Scuzzy commands. That the green tab is actually helping you out. So what exactly you wanted to do. So iSCSI helps you in all those things. And iSCSI, one of the major or one of the additional feature is that iSCSI helps me transport the traditional high performance block based storage. Block based storage means a complete partition of the hard disk. So iSCSI transport traditional high performance block based storage data over the common IP address. So you need not to invest in specific SAN switches, your HBA card or controllers. So you are saving all that money. So big, and because it is over the common IP network, it can be used for remote mirroring, remote backup, and other applications. And because IP network has no distance limitation, you can access a server in the US. So that makes it much more easier to implement, as it doesn't have any distance limitations. So as you can see it on the screen, a user wants to access the data from a file server. It gives the iSCSI commands. The server converts the the Scuzzy command into the iSCSI. It encapsulates it and send it over the network. So the traditional block-based transactions can be done over the IP network, and it is built on two common protocols, Ethernet and Scuzzy. So what actually happens is that using the ordinary TCP/IP network, iSCSI transport block level data between the iSCSI target or the actual storage device where the actual storage is, and in between the initiator, the client. So the server with the initiator on your right hand side is actually the storage, the iSCSI server, and on your left hand side, the point number 1 is actually your initiator, the client, which is accessing it. So it sends the packet, encapsulate the packets, the SCSI commands in the TCP/IP packet layer, and it transfer it. And the packets are then sent over the network and using a point-to-point connection. And once they received there, they are again, the protocol translate the data back to the SCSI. One of the major benefits, the primary benefits of the SCSI is that number 1, no distance issues. Number 2, lower cost. You can use the traditional or the commodity hardware, need not to purchase high-end SAN devices or switches. You need not to do anything. It's a well understood technology. High availability or something called multipathing is available. So in case the one switch goes down, it will automatically route itself from a different switch. And it gives me a better performance than NAS. These are one of the major benefits. How it works? The 2 protocols are there which actually helps in locating the server, the point number 1, that where the target is. Point number 3, they use 2 protocols are commonly used these days, SLP, Service Locator Protocol, and the ISNS, Internet Simple Name Server. So once we have understood how the things works, the next step is let's configure a iSCSI server and a iSCSI initiator. And as I have told you, it's an exam objective also. So you have to be careful in now what we are doing. So let's start configuring one machine as iSCSI server and another machine as the iSCSI target. And as I have told you, it's an exam objective. So you have to be careful in what we are doing it. So let's do this now. So it's a time now to configure iSCSI target or the storage on server 1. So the steps are very simple. Number 1 thing, you need to find out or check whether the required package target CLI is installed or not. If it is not, so I'll be configuring server 1 machine, this machine with a blue background as my server or the storage server, and the machine with the pink background will be my iSCSI initiator or the client. I just need to install the package. So as I have told you, it's an exam objective also, so you need to take care. So first install the package. Let's wait. That's great. And make sure we enable it. Systemctl start target. This is the package name. And enable it. Systemctl enable target. So the package is available after the reboot. And in case the firewall is on, so you need to add the port 3260 in the firewall. So if I give the command firewall cmd -list -all, I don't have the firewall running just for the sake of simplicity, but in case it is on, so you need to add the port 3260. Now I have this LVM already created with the name of iSCSI, which I will be using to share as a block device. So in the exam also you will be asked to share a LVM already configured there for you. So it's very simple stuff. You just need to, if I give a LV display, I will be getting the full name of the device, the actual, I can copy this for the future reference. Now just give target CLI and press enter. That's all. It's very simple stuff. If you give a ls here, you'll see these are the things that you need to configure. Backstore. Backstore means the actual hard, the partition or the block device which you want to access. So my backstore will be my LVM, this LVM. So let's configure step by step. The first thing, configure the backstore block device. So if you move inside this, or you can see here, it's a kind of a hierarchy slash backstore block. So give here slash backstore block. It will automatically comes, and if you do a double tab here, it will show you all the options available here. So obviously I'll be doing a create. So create, give it any name. Say I give server1 dot disk 1, anything. And the actual device behind this is the dev vg1 ISCSI. So I just created a block device. So if I again give ls here, you'll find this server 1 disk is coming up here of approximately 1 GB in size. Okay, now I need to create a ISCSI name for this. So now I will be giving here something like this. ISCSI, again do a double tap here. See here, I can straight away jump from this backstore to ISCSI. If I am going inside backstore, then I have to use /backstore/block/5. But as it is in the top level location, so just give a ISCSI create. Now this is a ISCSI qualified name, or we call it IQN. All the ISCSI devices need to be accessed by IQN name. So you need to remember this naming convention, IQN, then the year. So in my case I give 17, month is 5, and then the authority who has this. So I give, in my case I'll give my name, com example, whatever domain, and the identity. Say I give server 1, anything. So this is created. So if I give a ls once again, you will find one ISCSI qualified name server 1 is created. That's great. But who can access it? Who can access it? I've just created this. So now I need to create a ACL, access control list, that this block device will be accessed only by this machine, the second machine. So here I need to find out the ISCSI name for this machine. So this is very important. So you go to ISCSI initiator name. This is the name by which ISCSI recognizes this server 2, by which ISCSI server recognizes this server 2. So if you want, you can change it to a meaningful name. So let me just change it, ISCSI initiator name, and let me change it to something which I had already used. So instead of 1994, I give 2017-05.com example. So let me give it a meaningful name, say server 2. So this is the name or ISCSI initiator name. So this device or this machine is identified by ISCSI by this name. So do a cat of this file now, and whatever name is there, this is the name that you want to give access, right? So I copy this. Now what? I go here, I need to assign a ACL. So if I go here, so the block device is assigned, a name is assigned. So who can access this name? That is the ACL part. So I give here ISCSI /ISCSI, step by step, ISCSI ACL, right? ISCSI your IQN, your ACL, sorry, TPG and ACL. Now if I again press a double tab here, I will get all the options. So I'll be doing a create. I'm creating an access control list, and I paste that name, server 2. That's great. So if I again do a ls here, you will find it that this ISCSI qualified name can be accessed only by this machine. That's great. Now which LUN or which backstore is there? This is merely a name which is accessed by this machine, but which hard disk it's going to supply? So this one, this is the block device. So I need to create a LUN, logical unit number. So again, now in the third step, actually I'm adding this is merely a logical name, it doesn't have any block device, so I need to add a block device inside it. So I give a ISCSI IQN and LUNs, sorry, TPG and LUN. Again LUN create, simple, LUN create. Which name I will be giving? I will be giving this name. Copy this and paste it here. Oh sorry, it should be /block, sorry, it should be /backstore and block, sorry, it should be, give the same path, like simply, that's it. It works now, created LUN. So if I again give a ls, you will find here this block device is inside this ISCSI qualified name. So this is the name by which the ISCSI block device will be recognized. It will be accessed by the machines having name under the ACLs, and this hard disk will be catered. Now the last thing I need to do is that I need to create a portal, means which particular IP it should be listening to, which will be my IP. My IP is 192.168.0.100. So we have all the things configured here. The backstore is configured here. The IQN logical name is assigned. The machine who can access it under ACLs is coming up. Actual block device is coming up. Now the last thing is that I need to assign a portal. So portal means which particular IP it should be listening to. If you see here, I have got one portal 000 already defined. So if I give this command ISCSI IQN TPG portals and I give a create and my IP address, you will see it will give me error. One port, because there is already one port, so I need to remove this port first. So in case this comes, so just give a delete 0.0.0.0 IP underscore port 3260. Oh, this is IP underscore port, I suppose. IP underscore port equal to, sorry, IP underscore port equal to 3260. So it's very easy. If you do any silly mistakes, it will automatically prompt you up. So it had deleted it. So if I don't have a portal, now I can safely give this command portal created. So while creating it, you need not to define the port number, it automatically takes it. My job is done. So this is how you have just configured a iSCSI storage or the target. I can exit it and come out. It will automatically save the configuration in this file. If you are interested and want to save the configuration, keep a tab of this file. So this is done. Sorry. Now we have to configure the client, because the client ultimately need to access it. So I'll just close this one, not require. If I go here, this will be my client. So here I just make sure I have got a repo list coming up here. On the client side, you need to install a iSCSI initiator util package. Number one thing. Okay, this is installed. That's great. Now make sure your iSCSI name is the same name, which we had already done it. So in the exam also you will be asked to configure a specific name to the client. So you should be doing this. Now I will enable it. systemctl start iSCSI and systemctl enable iSCSI. So on the server or the storage side, it is the target, and on the client side or the initiator side, it is iSCSI. Now I will be giving a discovery command, very simple, iSCSI admin -mode discovery using the SLP protocol -t send targets and their portal name. So your portal name was 192.168.0.100. So let me give this, yeah, see here, it's showing me the IQN number, the iSCSI block device which is being shared. Copy this, and before I proceed further, if I give a fdisk -l here, you will find this is my hard disk, SDA SDB. I don't have anything other than SDA SDB. That's great. So discovery will show me the yes, that this device blocked storage is available. Now I need to do a login here. So for logging, you need to copy this name and then give the command iSCSI admin -m node -t, paste the name of the iSCSI block device and the portal name. Portal is 192.168.0.100. Just do a -l. -l means login. Successful. You see here, it's successful now. So if I do a fdisk here, you'll find SDC coming up here. So for the client, see how interesting it is. If you had already done this and the client is giving the fdisk -l, he will never came to know that from where exactly this 1 GB or 1 terabyte is coming up. So for him, it is a locally accessible device. So if I give a lsblk, it will show me. SDC is a simple device. So I can get a more information about my device that which are recognized. I can very simply give the command iscsi admin will help me. iscsi admin -m sessions, and I can say the last 3 or whatever, sorry, small p. So I can give this, give a -p1. Okay, just give iscsi help. I think something else here. Print level. So this is the print level. So iscsi admin, I'm not giving -m, it is actually session, not sessions. So I give a 3 here. So this is the information about my storage, that this is the device coming up here, initiator name is this, and a lot of information will be coming up here. That's good. Now once it is connected to me as a hard disk, I can format it, mount it, and use it. And in case you want to like, though it is not required right now, so let's do format this, mount this in a folder, as it will be coming up in the exam also. So I give a SDC here, and you know how to do it. So what I'm doing, I'm going to create one primary partition. I'll use the complete space. That's great. I do a write here, and if I give a fdisk-l, it's coming up SDC1. Obviously I need to do a part probe. Now I've got a fdisk-l. I'll give a SDC1. Let's format it using any file system, say XFS. You'll be asked to do this in the exam. That's great. I had formatted this. What next? I can mount it and use it. So I can create a folder here and mount it and use it. Let me just create a folder. mkdir, say iscsi data, anything. So if you give a block ID, you can access this SDC1 with this UUID or SDC1. It is up to you. We had already learned all these things. So for making a permanent entry, obviously you will be going in the FS tab, and I drop the mic, so, and paste it here, remove the quotes, simple stuff, and mount it on, say, my iscsi data. File system is XFS, permissions are defaults 00. Save and come out. So if I do a mount all, I give a df-h, it is coming. So if I store anything here, if I store anything on the folder iscsi data, it is actually going onto my iscsi block device, which is on server 1, and so it should be available after the reboot also. And actually one very interesting thing or important thing that you need to do and need to take care in exam, you should be giving here netdev underscore netdev, as it is a network device. So instead of default, right here netdev network device. Though the scanning is not required, you can do it. Dev df-h, it is there. It is how you use this iscsi initiator and the iscsi server. So this is what you have to do in the exam. Now one very important thing and the last thing in this particular lab is that when you reboot, it might gives you issues. So what you do as a precaution before doing a reboot and confirming it and then checking it in the exam, just unmount it, as the information is already in the FS tab, and give the same command here, just log out, because once it log in, just do a -u, log off. You have successfully logged out. Now do a reboot. So let's see, because when it comes, it will automatically read the configuration from the file and should be able to mount it successfully. So don't forget this step. So just wait and see if it is coming up successfully or not. Seems good to me. So far so good. Yeah, I'll just do a login here, and if I go back, just open this. Let me make sure my connections are perfect. Just connected. Let me, because I have got a multiple interfaces, so sometimes they don't work as per my wish. So just for the aesthetics, my IP should be coming up here 200. That's great. And if I give a df-h, it is there, iSCSI data. So please don't forget to do a unmount before the reboot and then log off and then do the reboot. These steps are very important. So this is for the day to configure the iSCSI target and the iSCSI initiator. And as I have told you, this is an exam objective. So I'll see you in the next class. Bye bye.